We're going to do the same roller coaster problem, but I'm going to show you a different way that you can find those x-intercepts. Again, we had discussed that we needed to find the x-intercepts of this second interval, interval B, so that's what we're going to be doing. So what we're going to do is, again, make the realization that 2 and -1 are zeros from the picture. Then we're going to set up synthetic division, and we're going to choose one of these zeros. It doesn't matter which one you choose. You can do 2 or -1. In my example, I went ahead and used -1. So if we were to synthetically divide by -1, obviously we have to get a remainder of 0. If you use an x-intercept, you have to get a remainder of 0. That's going to always happen. And then we're going to convert our synthetic division to factored form. So we'll have t plus 1. So that -1 transpires to t plus 1. And then we'll have a 4t squared minus 25t plus 34. So remember, everything drops down a power whenever you have an answer to a synthetic division problem. Now, in the previous method, we had gone on and did another round of synthetic and tried to factor this part down. We're not going to do that today. We're actually going to use a quadratic solving method. If I'm trying to find x-intercepts, then I take this parentheses and set it equal to 0. And we have a lot of techniques to solve that equation. We can use quadratic formula, we can use complete the square, we can use factoring. We're going to use the quadratic formula because that seems to be what most kids use. So we set up our quadratic formula, opposite b, plus minus square root of b squared, etc. So when you set up your quadratic formula, it's a good idea to show me what numbers you're plugging in where. And then you can tell me what you get under the radical, because that's usually where kids make a mistake. After that part, I don't really need to see any work. And you will get 2 and 17 over 4. So you knew that -1 was a 0. And there's that 2 that is also a 0. But your quadratic formula will also give you that 17 over 4. So nothing wrong with using quadratic formula if your sole mission is to find x-intercepts. Nothing wrong at all with that. Here's what does go wrong. If I scrap this problem and I go ahead and say, hey, let's pretend that this is the volume of a cube, or excuse me, a rectangular prism. This is the volume of a box. Go ahead and tell me the dimensions. So kids will say, well, one of my factors was t plus 1. If you get 2, that means t minus 2 is a factor. And if you get 17 over 4, that means -17 over 4. T minus 17 over 4 is a factor. And then kids will circle this and say, here's the dimensions of this box. Here's the length, here's the width, here's the height. The issue is, if I FOIL this back together, I do not get 4t cubed. So if you have directions that say factor this polynomial, and you use the quadratic formula and try to cheat in such a way, if this answer does not FOIL to what it should FOIL to, you will not get full credit for it. So t minus 17 over 4 and 4t minus 17 both get you the same x-intercept, but obviously they're different. So that's why I kind of steer away from quadratic formula if you have to factor. I try never to use quadratic formula if I'm factoring. I use an actual factoring method. So just that's something to be cautious about. But again, it depends on what the directions of the problem say. If you just need to find the x-intercepts, go for it. But if you need to factor or find dimensions of a box, which would require factoring, you really shouldn't use that quadratic formula. So the one thing we don't want to forget is we need to answer the actual question. How long was the roller coaster at or below ground level? So, well, interval B took place between 2 and 4.25 seconds. So the roller coaster would have been underground for 2.25 seconds. So we're going to do another word problem. It's very similar to the one we just did. We're just kind of reiterating that whole concept of using synthetic division to help us factor. So we have a roller coaster. It's the graph of a cubic. The only thing is the little hills here got kind of cut off because I graphed this on Desmos and it shrinks the graph in so much that you can't see it. But this does look like a normal cubic function. Obviously, it's got some manipulations, but it does follow that shape. And I once again want to know when it's at or below ground level. So there's two intervals that happens. From this point and to the left, you're going to be under the y-axis, or excuse me, under the x-axis. And between these 2 points, you're going to be under the x-axis. So there's two intervals where the roller coaster is underground. But once again, we're going to reject interval A because that would be involving negative time, which doesn't make sense in the context of this problem. So we are focused on interval B. Now I can see it looks like the roller coaster went underground at 1 second and it came back up a little after 10 seconds. I don't know what that is. Is it 10.3? Is it 10.5? 10.2? I don't know. So we're going to have to work to get that. We have zeros at -2 and +1, so we can use that to our advantage. And we're going to start by using synthetic division and our zero. So here's my coefficients. It doesn't matter if you want to use 1 or -2 first. Either one is fine. I went with -2. And then we do a real quick round of synthetic division. And you should get a remainder of 0. So then I take my synthetic division and I convert it into factored form. So the -2 transpires to be t plus 2. And my answer, my quotient, becomes 2t squared minus 23t plus 21. I want to continue factoring my quadratic, so I'm going to do another round of synthetic since I have another 0. So I can do 2, -23, and 21, and synthetically divide that by 1. Again, should get a remainder of 0. So I'm going to keep my t plus 2, but when I factor this quadratic, I get t minus 1, and then my leftover of 2t minus 21. So I could use 2 rounds of synthetic division to factor this polynomial. Once you have something factored, you can set each of them equal to 0 and solve. So there's your -2, there's your 1, which we already knew were there, but what we didn't know was the 21 over 2, or 10.5. So interval B takes place between 1 and 10.5 seconds. So if you subtract that, you can go ahead and say, oh, it was underground for 9.5 seconds. At or below ground level, I should say. So in my next video, I'll go ahead and go over wording number 3 because that one is, in my opinion, that is much more complicated than the previous word problems. There's some danger games that you could be playing with this problem, so we'll take a look into that.